Phase 4, according to insiders, involves stress testing under variable conditions. This wasn't about pushing maximum output, it was about observing how the device behaved when the environment changed. Temperature fluctuations, simulated power surges, and extended runtime were all part of the regimen. Supporters say MSED maintained remarkable stability, but skeptics point out that controlled lab conditions can mask potential real-world vulnerabilities. Meanwhile, behind the scenes, engineers were reportedly analyzing energy conversion efficiency. Every watt generated versus input measured, every thermal spike logged, every anomaly flagged. The goal wasn't to prove hype, it was to understand the system's mechanics and whether it truly represented a paradigm shift. But as the technical evaluation proceeded, whispers about Elon Musk's alleged presence in the testing area fueled global curiosity. Analysts, journalists, and social media users began speculating on possible collaborations, investments, or even future commercialization. Rumors spread faster than verified data. Screenshots, blurry lab images, and unverified testimonies circulated, feeding both excitement and skepticism. And that's exactly the challenge for disruptive technologies. Perception moves faster than verification. A single mention by a high-profile figure can amplify every claim, regardless of technical maturity. Yet inside the lab, the focus remained unwavering: performance data. Observers reportedly noted the device's silent operation, the lack of exhaust or fuel consumption, and a consistent output under varying simulated loads. Engineers described it as anomalously stable, and no one outside the immediate testing team could access the raw logs. What happens next is where the story gets pivotal. Independent verification is essential. Replication under different conditions by separate teams in varied environments will ultimately determine whether the MSED device can deliver on its promise, or if the alleged test was a controlled outlier. But even at this stage, the implications are hard to ignore. A working, self-powered energy device would redefine energy economics, challenge centralized grids, and shift the focus toward off-grid, resilient power systems. Entire industries could pivot. Governments could reevaluate energy policies. And the global perception of African technological innovation could reach unprecedented heights. The test may have been small in scale, but its symbolic impact is enormous. It demonstrates that ideas previously thought impossible are being explored, tested, and potentially validated. The response, when it comes, won't be gradual. Disruptive technologies don't trickle into markets, they shift them overnight. Investors will reassess risk. Utilities will reconsider dependency. Governments will explore policy changes. And the conversation around energy access will pivot from scarcity to opportunity. For the MSED device, the stakes are even higher. It's not just about energy production, it's about autonomy, resilience, and strategic advantage. Imagine critical infrastructure running independently of traditional grids. Imagine remote communities gaining reliable power without waiting for national expansion. Imagine industries being able to operate in environments previously considered too unpredictable. And the media? The narrative will explode. Every alleged detail will be re-examined. Skepticism will collide with curiosity. Analysts will debate the physics. Technologists will propose enhancements. And in the midst of this storm, the truth, what the device actually does, will become the anchor everyone seeks. That's why controlled verification is crucial. Without independent, repeatable tests, MSED remains in the realm of possibility, not certainty. But even the possibility alone is enough to alter perception, and perception drives funding, adoption, and policy faster than raw data often can. The next logical step is pilot programs and scaled demonstrations. A single, verified deployment in a real-world setting could silence doubt and ignite interest worldwide. And if the device functions as alleged, the conversation won't be about feasibility, it will be about how fast it can scale. Yet with scale comes complexity. Regulatory compliance, safety standards, intellectual property management, and logistical considerations all become central. The simple act of turning a lab-tested prototype into a deployable system requires as much strategy as engineering. But the first test, alleged as it may be, already changed the conversation. It moved MSED from theoretical concept to global phenomenon. And now, the eyes of the world are watching, waiting for the moment when possibility becomes reality, and that question, who gets access first, carries enormous implications. Early adopters could gain a strategic advantage. Corporations might cut operational costs, cities could achieve unprecedented energy resilience, and research institutions could explore new frontiers of science without worrying about power limitations. Conversely, those left behind could face a widening gap, unable to compete or even maintain basic operations under conventional energy constraints. That's why the rollout strategy appears so deliberate. Limited deployment, selective partnerships, and staged verification are not obstacles, they're safeguards. They ensure that when the technology reaches broader audiences, it does so reliably, legally, and sustainably. At the same time, anticipation continues to build. Analysts model potential energy savings. Governments evaluate policy shifts. Industry insiders speculate about licensing, collaborations, and the competitive pressure this device could place on existing energy providers. Every rumor, every partial disclosure, fuels further interest and further scrutiny. And yet, amidst all the speculation, the core principle remains simple. Data is king. Every claim must be backed by measurable, reproducible results. Without that, hype will outpace reality, and perception could easily overshadow performance. But if the MSED device consistently demonstrates what it allegedly achieved during the initial test, the global energy paradigm could shift permanently. Grid dependency could diminish. Fossil fuel reliance could shrink. Entire regions previously considered energy poor could gain autonomy. And a technology from an African inventor would take its rightful place in the narrative of global innovation. The tension is palpable. Observers outside the lab wonder, question, and debate. Engineers inside the lab measure, test, and record. And the world waits. Because the story of the MSED device is not just about a test, it's about what happens after verification, when reality catches up with speculation. The headlines were impossible to ignore. Elon Musk reportedly tests MSED device. Game changer or hoax? Energy revolution or internet hype? And suddenly, a story that began in quiet labs in Africa was being whispered in boardrooms, forums, and social feeds worldwide. But here's the catch. No one outside the test saw it directly. What circulated was a mix of speculation, blurry images, and statements from sources with varying credibility. Some claimed first-hand accounts. Others relied on second-hand reports. And the line between fact and narrative blurred almost immediately. So, what really happened when the MSED device was allegedly tested? The first thing to understand is context. MSED isn't a consumer gadget. It's a self-powered energy system, reportedly capable of generating electricity without traditional fuel sources, grid dependence, or conventional batteries. Its potential alone makes it a high-stakes subject, and naturally, anyone associated with it, including Elon Musk, if the reports are accurate, attracts intense scrutiny. According to sources close to the testing environment, the device was evaluated under controlled conditions, with multiple measurement instruments capturing voltage stability, energy output, and operational consistency. Observers described the environment as tightly secured, with only essential personnel present. No flashy demonstrations. No grandiose press releases. Just a methodical, cautious test. The results, as reported, were simultaneously impressive and hard to interpret. The device maintained stable energy output over extended periods. There were no visible spikes or drops that would suggest conventional power generation. And according to insiders, it operated quietly, without exhaust, combustion, or any external fuel input. For engineers and energy analysts, this raises immediate questions. Is the output consistent with known physical laws? Could the readings be misinterpreted or influenced by calibration errors? And crucially, what is actually being measured versus assumed? This ambiguity is why public reaction has been polarized. Some see it as a breakthrough that challenges everything we know about energy. Others see a carefully crafted narrative, a device performing under controlled conditions, framed as something more revolutionary than the evidence supports. But whether breakthrough or hype, the alleged test achieved one undeniable outcome. It captured global attention. Energy companies, aerospace engineers, and technology analysts suddenly focused on a story that had previously existed only in niche circles. Social media debates erupted. Forums lit up with speculation about patents, replication, and potential collaborations. And for the world outside the lab, that was all anyone had to go on. What remains uncertain, and what this video investigates, is the intersection between observed performance and actual verification. Because until independent testing, long-term monitoring, and third-party replication occur, the line between alleged and confirmed remains critical. Yet, even in ambiguity, the implications are profound. If the MSED device truly functions as reported, it could redefine energy access, shift power economics, and introduce a technology previously thought impossible. To understand the full picture, we need to break the test down into phases. Phase 1. Activation and baseline measurement. According to insider accounts, the device was powered up in a secure lab, with all energy outputs carefully logged. Observers report that initial readings showed immediate stabilization, a rare feature for any experimental energy system. Most devices in testing fluctuate wildly at startup. MSED reportedly did not. Phase 2. Load testing. Small-scale loads were applied incrementally, simulating real-world energy demands. Lights, motors, and other standard electrical equipment were used to gauge response. Sources claim the device handled these loads without significant variation in output. In other words, it performed like a mature energy system rather than a prototype. Phase 3. Sustainability and endurance evaluation. The device reportedly ran continuously under load for hours. No refueling, no battery swaps, no external power input. If these reports are accurate, it demonstrates an unprecedented level of operational consistency for a self-powered system. However, caution is essential. Energy systems are notoriously sensitive to environmental conditions. Temperature, humidity, and even electromagnetic interference can create anomalies in readings. That's why skeptics stress the importance of reproducibility. One successful test, no matter how promising, is not enough to confirm revolutionary claims. At the same time, supporters argue that MSED's performance, even under controlled observation, hints at a fundamentally new principle in energy generation. It's not just a more efficient generator. It's a system that bypasses traditional constraints, potentially providing a continuous, self-sustaining energy source. And this is where the controversy intensifies. Elon Musk's alleged involvement only amplifies scrutiny. When someone of his stature is connected, even indirectly, to a technology, the media and public reaction is magnified. Every detail is dissected. Photos, statements, even rumors about what type of lab equipment was used. The narrative shifts from technical evaluation to almost mythic speculation. But within the lab, the focus remained on data. Voltages, amperages, thermal profiles, and system stability, every parameter meticulously recorded. Observers describe an atmosphere of disciplined experimentation rather than spectacle. Yet, outside the lab, attention was already moving toward potential implications: energy independence, off-grid applications, emergency power solutions, and even aerospace or industrial adoption. This duality, quiet technical rigor inside, global speculation outside, defines the MSED story. And the next step is the most critical: verification by independent third parties. Until that happens, the device remains allegedly tested, no matter how credible the initial reports may seem. Because in technology, especially something this disruptive, confirmation is everything. And that brings this story to its close. The MSED device, whether a revolutionary breakthrough or a carefully controlled experiment, has already reshaped the conversation around energy, innovation, and possibility. Its alleged test captured global attention, sparked debate, and forced industries, governments, and innovators to reconsider what's possible. For now, the technology remains under scrutiny, access is controlled, and verification is ongoing. But the implications are undeniable: A system that operates independently, reliably, and sustainably could redefine the future of power worldwide. When the full truth emerges, it won't just answer questions about performance or cost. It will redefine who controls energy, how it's distributed, and what the future looks like for all of us.